So Janelle is a carpenter and Tanya is her apprentice. So they're going to be working on a job here. So Janelle and Tanya. And then what do we always do at the top? Remember the two things? Time and rate. And then we're always remembering rate is how long it takes somebody all alone to finish a whole job. That's what rate always is. Okay. It takes Tanya 18 hours longer to install than Janelle. Working together, they can install the floor in 12 hours. Okay, so this 12 hours, that's the time, because that's when they're working together. Okay, I don't know Janelle's rate and I don't know Tanya's rate. So that's not good to not know two things, but it takes Tanya 18 hours longer than Janelle. So 18 hours longer than Janelle. Does this make sense? I don't know Janelle's and I don't know Tanya's. Okay, but we can't use two unknowns. Right? In math, you can't use two variables that you're figuring out. So I'm going to say Janelle, I don't know. Tanya is 18 longer. Okay, so then when we set these problems up, we do time over rate equals job, right? Time over the rate. So 12 over J, Janelle's job, plus time over rate, Tanya's job. Together, they do the whole job. Okay, so this is the same as yesterday in that sense. It's just that this is a little bit different right there. Okay. Cross multiply or common denominator would be my next thought. So common denominator. Because I have three fractions, not a 1-1. Okay, what do I all need as multipliers? I need a j and a j plus 18. Right? I need those two factors. So that's the common denominator. And what am I going to multiply this fraction by? I'm going to have to multiply it by j plus 18. What am I going to have to multiply this fraction by? A j. And then when I write the 1, I'm just going to think the same thing over the same thing. Or you can think, what do I multiply by? You had to multiply by everything. Okay, so here we go. 12j. I saw some calculators pop out. Did anybody do that one already? 12 times 18? 216 plus 12j. Okay, drop the bottoms now. So the top, which is, can I put the 12j's together? 24j plus 216 equals, and then are you okay on this side if I'm doing that? J squared plus 18j. Okay, this is your big, shining grade 11 moment. What are we going to do? I see j squareds and j's in all this. What's the biggest thing we should think about right now? Simple trinomial, but 1 equals 0. That's the big idea. You have to have everything on one side before you think about what to do. So I'm going to go, you know what, j squared is the boss, because I like the squareds positive. So everything I'm going to go that way. So 0. So I'm going to be subtracting a 24j and subtracting a 216, right? So j squared, 18j subtract 24j is negative 6j. And simple trinomial. So j times j. And I'm going to think of two numbers that multiply to 216 and make a 6. That's probably would take you a long time on your calculator if you were just guessing. But do you remember up here? 12 times 18 was 216. So 12 times 18 makes 216. And I need to add to negative 6. So j equals negative 12 and j equals 18. Okay, so j is representing Janelle's rate to do the job. Can Janelle take negative 12 hours to do it? No, that doesn't make sense. So Janelle would take 18 hours alone. And Tanya, do we remember Tanya? She takes 18 hours longer. So what would her time be on the whole job, the rate? 36, right? 18 hours longer. Okay, number 6. A cyclist rode from town A to town B and then back. So this is what happened. A cyclist went there and then back. A distance of 3 kilometers each way. So that distance is 3 kilometers. On the trip there was an 8-kilometer-an-hour tailwind. On the return trip, there was a 6-kilometer-an-hour headwind. This is now what I'm going to use for my equation. The total riding time is 5 hours. Okay, so the time there plus the time back is going to add up to 5. However long it took you to get there plus however long it took you to get back is 5. Okay, what do we got? Do you remember what time is again? Velocity was distance over, no, kilometers per hour. So time equals distance over velocity. Okay, I got my formula. Time is distance over velocity. Okay, you ready? talk about on the way there. What's the distance? On the way there, what was the distance? 3. What's the velocity going there? What's the velocity? So your bike speed, right? And what do we do with this 8? It's in tailwind on your bike. So plus 8. On the way back, ready? I'm looking at this fraction. What's the distance you've gone on the way back? 3. The velocity is your bike. What happens when you have a headwind? Minus your speed, right? We had a headwind on the way back. Okay, we're okay with this? Cross multiplier, common denominator, drop. Common denominator. What are all the multipliers I'm going to need in there? I need a b plus 8 and a b minus 6. Okay, now I look at the first fraction. What am I going to have to do to that fraction? Multiply by a b minus 6. So 3b minus 18. Looking at the second fraction, what am I going to have to do to it? Multiply by b plus 8. So plus 3b plus 24. And what am I going to have to do to this fraction? I'm going to have to multiply it by both things, right? Do you see the bottom? So I'm going to have to multiply by both things. Ooh, I should not have picked a b. The b and the 6 are. Okay, at this point I'm dropping the bottom. So this top is 6b plus negative 18 and 24 makes 6. Okay, on this right side, here's where I've said before, you have 3 things getting multiplied. So pick 2 things, just do the 2 things that you pick, and then by the third. So I'm going to pick these 2 things to multiply, and then eventually by 5. Okay, I'm going to FOIL this, and I'm going to combine the outside and inside. So b squared, first times first. Outside is negative 6b, inside is plus 8b. Can you put those together already? Negative 6 plus 8 plus 2b. And then the last is minus 48. Okay, and it's your factoring, thinking about factoring backwards. Like, what do those multiply to and what do they add to? Okay, now I'm going to multiply by 5. So 5b plus 5b squared plus 10b. Has anybody already done this number?
I got negative 240. Yep.
Negative 240. All right. This is what we look like. Ready? Algebra. Can I isolate? Nope. I can't isolate because I have b squareds and b's. So what's your first math instinct? Equals 0. So minus 6b and a minus 6. Okay, now this quadratic does not look very nice for factoring, does it? And if we flow this, that's like a massive number and getting multiples of it to try to get to 4. It might not even factor. What else do I have? What's that? The formula. So I have a quadratic formula. Okay. Negative b, so negative 4, plus or minus the square root of b squared, so 16, minus 4 bracket 5 bracket negative 246, all over 2 times 5. Okay, so I'm going to, obviously the bottom I just made a 10, the 2 times 5. And I'm going to calculate that part. I got 4,936. Okay, that is why we probably wouldn't have factored it, because that's not a perfect square. Okay, so can you remember how to type those into your calculator? Get me the 2 options, so make sure you think about how to type that in with brackets. You know what I realized? I shouldn't have used an x, because I told myself my variable was a b, but I guess if I call it a b, I should leave it as a b, not an x. Okay, how are we with the matching what I have? Anybody getting those numbers? 6.63? Okay, do you remember what we were solving for? The bike speed. Okay, well that one doesn't make sense. I can't have my biker going that. So 6.63 what? Kilometers per hour is the speed on the bike. So Mia, is that a fast biker or not?
No.
No, what's your speed?
I don't know.
What? More than that? Like what is a good bike speed? I don't even really know. Compared to a car on the highway. You probably pass all the cars on the highway or what?
No. That would be like